In this example, I'm given that f of x equals x squared minus 8x minus 5. And I need to evaluate these following four expressions. In part A, I need to find f of negative 2. Remember, the negative 2 is going to replace the x. So wherever you see an x in the definition of f, I'm just going to replace it with negative 2. So it's going to give me, instead of x squared, I'm going to have negative 2 squared minus 8 times x. Well, in this case, x is negative 2. And then finally, don't forget the minus 5. Now all I have to do is evaluate this arithmetic expression. Negative 2 squared means negative 2 times negative 2 is positive 4. Negative 8 times negative 2 is positive 16 minus 5. 4 plus 16 is 20. 20 minus 5 is 15. So f evaluated at negative 2 is equal to 15. In part B, I need to find f at negative x. So what this means is I'm going to take my expression negative x and replace it for every x in the definition of f. So I'm going to get, instead of x squared, it's going to be negative x that I square minus 8 times, instead of x, I'm going to have negative x, and finally minus 5. So that's going to give me negative x all squared is negative x times negative x is positive x squared. Negative 8 times negative x is positive 8x minus 5. So that is f evaluated at negative x. Next, in part C, I need to find f of x minus 3. So what that is going to give me is, instead of x squared, I'm going to have x minus 3 all squared minus 8 times, instead of x, I'm going to have x minus 3, and then don't forget the minus 5. Now, the first thing I need to do is evaluate x minus 3 all squared. There's a couple of different ways of doing this. I'm going to show you both. X minus 3 all squared can be written as x minus 3 times x minus 3. And then we can just FOIL this out. First, x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So this is going to give me x squared. Negative 3x and negative 3x adds up to negative 6x plus 9. Now that's the longer method for squaring a binomial. The shorter method is you take the first term and square it. Well, x squared is x squared. Then you take twice the product. 2 times x times negative 3. Well, 2 times x is 2x. 2x times negative 3 is negative 6x. And then the last term is negative 3 all squared is positive 9. It doesn't matter which method you use the one you feel most comfortable with. So now I'm going to get x squared minus 6x plus 9. Distribute in the negative 8. Negative 8 times x is negative 8x. Negative 8 times negative 3 is positive 24. And then the minus 5. Now all we have to do is collect up like terms. There are no like terms with the x squared, so I'm going to get x squared. Then I have negative 6x added to a negative 8x, which is negative 14x. And then I have constants, 9 and 24 is 33. 33 minus 5 is positive 28. So f of x minus 3 is equal to x squared minus 14x plus 28. And lastly, we need to find f of x plus h. So wherever we see an x up here, we're going to have to put x plus h. So instead of x squared, I'm going to have x plus h all squared minus 8. Instead of x, I'm going to have x plus h. And then finally, the minus 5. Next, we need to simplify this expression. So squaring this binomial, I'm going to do this by the shortcut method, but if you want to write it out this way and use FOIL, that's fine too. Shortcut method says take the first term and square it. X times x is x squared. Twice the product, 2 times x times h is 2xh or 2hx. It doesn't matter which way you write it. Since multiplication is commutative, then take the last term and square it. H times h is h squared. Now distribute in the negative 8. Negative 8 times x is negative 8x. Negative 8 times h is negative 8h. And lastly, minus 5. Are there any like terms here? No, there are no like terms. So that is the answer for f of x plus h. It cannot be simplified anymore.